Welcome to this video on database system. In this video, we are going to focus on vulnerabilities as it pertains to the architecture and design of the database system. Now, a database system is really nothing more than a piece of software that's going to allow you to collect, organize, store, and eventually query or access this data. So when you store this data in there, it will organize it in things like tables. There's query, there's all kind of different way to structure database. But for this video, we are going to focus primarily on vulnerabilities that will persist against a database system. Now, the primary way that you are going to interface with the database, certainly when it comes to the database management system, it's called structured query language. Now you can call this SQL or you can call this SQL. I have heard it referred to the both ways, and the database administrator will call this as SQL. Other folks will call it SQL. Doesn't really matter. At the end of the day, it is structured query language and it is used to manipulate data within rational databases. It also provides you a consistent language access, store and modify the database content, and SQL is probably the one of the most popular way to access database and manipulate the data within the database. Now, within database, a lot of things come from a schema, and this is going to define how the database is built and how to organize the data within it. The database table is the primary place where all of the data is stored within the database table. You are going to have columns or attributes, and you are going to have rows, also called tuples. Now, in a common speak, it's row and column. In the actual software language, it's attributes and tuples. So be aware of that, just in case you see a question on the exam. But database table is primarily where all of the data is stored. Now, within the database table, you can have relationship between those tables. So let's say we have single table and then we have another table in the database, and that's why they call it rational databases. And you also need a way to create that relationship for the database to understand how to collect information. So what we use in databases are keys, and primarily we are going to use primary key. So this is going to be a primary key and this is also going to be a primary key. The primary key in each table. Now what happens is, if these two tables want to create a relationship, one of them is going to have a primary key, other is going to have a foreign key. The primary key exists in the primary table, and the table that you are trying to reference in a query or something like that is going to be the foreign table, and that's why it's called foreign key. That's how you create the relationship. So when you actually make a query, what ends up happening is you are going to pull data. Let's say these attributes or columns are from a one table, and then these attributes here are from a second table. So what you are going to end up with doing is using that primary and the foreign key relationship, and you are going to pull information from those tables into a single location where you can access this data. So it's also called aggregation. So aggregation is combining data from multiple database table. As you build database, I certainly have some experience building databases, and what ends up happening is you will build databases that have information in one table. Then you will create another table and another table, and there will be 12. And then you have to be able to relate all the data to combine it so that you can use it. And that's what aggregation is all about. You might also hear of an aggregation attack, and this is where an attacker, somebody that maybe compromise your database, is starting to go through all those multiple tables and extracting that data using queries and other things to take the data out of all of those tables, so that they can perform what's called an interference attack. And this is where you are going to use all of this data, and you are going to draw a conclusion from that data using multiple pieces of information. And by using interference, this data might otherwise be hidden throughout this multiple table. So let me give you an example of how that would work. Let's see, we have a database table, then we have a secondary table. So what you need to notice right here is you have an employee ID, This would probably be your primary key in this table. So you want to connect those two tables together in a query, and ends up happening is maybe this third table, and now you have all these different attributes or different columns. So you can see employee ID, employee name, pay grade, and so on. But if you like to notice, employee name is only in one table, pay grade is only in another table, and then pay grade is found in another table with the pay range. So that the pay grade would have relationship as well. So this could end up being a primary key, and this being a foreign key over here as well. What ends up happening is, the way this is designed is, you want just the employee ID and the name. That way, if somebody were to compromise the table, that's all they would find. Once I start piercing together all of this data throughout the aggregation, because I have collected all this data, because she has a pay grade of 5, 6, 7, 8, 9, 0. 6, 7, 8, 9, 0, pay grade 5. Pay grade 5 gets paid 90 to 1,010,000 a year. That would tell me that Susan is probably someone senior in the organization. She would be somebody I want to target to maybe get her account information or somehow get some privileges that she might have. So this is how you infer this. So otherwise, if I just look at this particular table, there is no way for me to know how much Susan would possibly get paid. So I can draw conclusion that Susan is probably senior official in this company. She would be somebody I want to target. Other times we call this cell suppression as well, where we maybe hide cells from table. That way, if they were to be compromised, somebody could not actually infer the information from it. So hopefully this make more sense to you. Another concept to be familiar with, poly-instantiation. Let's say we have a database table, and of course we have our primary key, which is the customer ID. So what I want you to take note of is the customer ID. Notice that they are two of the same exact customer ID, and this is bad security incorporated. So they are in this table, but what I want you to notice is the data sensitivity over here. So what this has to do with is, when I go to make a query, if I want to make a query for this inside information, meaning this is sensitive information, that may be bad security. I did not want somebody to know. Maybe we signed a non-disclosure agreement with them. Maybe we have a service level agreement that says you can disclose certain things. Whatever that things might be, maybe they don't want the rest of the public world knowing that we perform a penetration test for them. Maybe they just want to know they purchase security consulting service from us, and that's where we would focus our query. We would set up query and say we want to use public related data for customer 98 to 4567, and then the query would generate the data, that poly-instantiation. The reason we do this is because we want to hide the most private data, the sensitive data. So you can see why this is important to understand. That way, when you are identifying your data types, the sensitivity level of those data types, this will allow you to plan and build proper security solution into your databases. Now, this is very simple example. Imagine if you are a face.com or instagram.com or amazon.com, and you are collecting large amount of data. You are going to need a data warehouse to store this data, and this is used to store large amount of data that's collected from all of different databases. So if you have several different databases, you can put it all into one area. Then you can mine the data, or data mining as it's called in the industry, and this is analyzing large amount of data to look for the different patterns and connection that you normally would not see. And that's because sometimes it could be within the metadata, which is information about the data itself, or it can just be buried within all of this large data that's been collected. Then on the other side, we also perform data analytics, which is the analysis of raw data to discover the any useful information we are looking for, like big data, other industry term, refer to the data set that are just too large for normal data analysis. So it requires high performance analytics to run in a parallel using distributed system and things like that. And then you have parallel data system which performs multiple data calculation at the same time. So you can see how that might be useful for big data. Okay, so now let's talk about the transaction that's happened within the data. I talked about using SQL or SQL to interact with the database. Now let's talk about how those transactions are done. And there's a framework you need to know for the exam. It's called ACID, and it starts with Atomicity. Atomicity are transactions that are complete one way or the other. The transaction will either completely succeed or completely fail, and there's nothing in between, and it basically stands for atomic. It means atomic, so the database will not change during the transaction. It will fail unless it absolutely succeeds. So if it is 100% successful, the database will make the change. If it is not 100% successful, the database will remain in the same state it was. And this encourage or ensure data integrity, and it also prevent something called dirty reads. A dirty reads occur when a transaction was in progress, it did not complete correctly, and then the data is incomplete. So the database doesn't know how to query it. It also doesn't know what to do with it. And if there's some rule set, it may not meet the rule set. So there might be some kind of state change that could impact the database. There's a C for consistency. This is where all data must comply with defined rule and constraints. So when we set up rules in terms of what the fields can look like, pretty much the schema, how everything going to work together, how the data constructed in the tables, those kind of things. If the data doesn't meet those rules or constraints, then it gets rejected. And consistency will help protect against things like lost update. That occurs when two different transactions are happening at the same time, and one transaction will step on top of other, override the other, meaning one transaction get lost and other transaction stored, and we don't know which of this is correct. So the consistency will help with that, as well as isolation. Isolation will make sure that all transactions are kept separate from each other. It enforces data concurrency, protecting against dirty reads and lost update at the same time. Then we have durability, and durability is all about ensuring completed transactions are stored and recorded safely. So in the event of a system failure, that data will remain intact. This model is important to know for the exam. So clearly understand each one of these things. So now let's talk about some security features and some security best practices for database. Obviously, as we talked about before, we want to enable only necessary components, services and communication protocol, and disable everything else. We want to disable or remove any unnecessary account or change any default password. A lot of database management system will come with a default account and password, so we want to make sure that we are changing those. We also want to set appropriate permission on database directories, data stores, log file and certificates. So the bottom line for database system is to understand what makes up a database table, also understand the aggregation and inference, understand the different method of data collection and analysis, that also include the ACID framework that we talk about, and know the database security practices.